This is video number 14 in chapter 12 of Anatomy and Physiology. So in our last couple videos, we talked about what an action potential is and some of the ins and outs of action potential formation, their frequency, the size of the stimulus, etc. Now we're going to look at how an action potential moves from point A to point B. So the whole purpose of a nerve is to get information from one part of your body to another, whether it be to your brain or from your brain. So we have to get that message out. And we know the message is a reversal of the polarity of the plasma membrane, which we call an action potential. So with action potentials, we know that action potentials are large changes in the membrane potential that travel along a nerve, and this is the key, without changing magnitude. So the strength of that action potential does not change, because remember that an action potential is all or none. So it is the same reversal, and it does not change that amount of difference in polarity along that nerve. So our question is, how? How does it travel? Well, an action potential in one location on the neuron, so the nerve cell, stimulates an action potential in an adjacent section of the same neuron. So it's almost like dominoes. It's a series of cascading action potentials. So an action potential in this part of the neuron, because we have that influx of sodium and an outflux of potassium, triggers an adjacent area to open the gates, which triggers in another adjacent, so it just cascades down an action potential. Now, action potentials travel in one direction, so they're one way. So it goes from the trigger zone to the synapse. So remember, the trigger zone is the start of the axon from the cell body, and the synapse is what occurs after the presynaptic terminals at the other end of the axon. So if a message is coming in from the dendrites or the cell body, it travels down into that trigger zone, down the axon, and out the presynaptic terminals into the synapse. And we'll talk about the synapse a little bit later. Now, you might say, why is it one direction? Well, the absolute refractory period prevents the action potential from reversing direction. So it can only go one way because there's that brief period where nothing can occur and it travels down that area. So if it originates in a trigger zone, that's the area that has all those channels. The cell body really doesn't, so then nothing goes backwards. So if this section, the channel's open and there's no channels on this side, this is the only direction it can start, and it goes in that direction. So if we start looking at unmyelinated and myelinated axons, we're going to see that there is a difference between these. So that myelination, if you remember, was an insulation. So an unmyelinated axon, the next action potential is generated immediately adjacent to the previous action potential. So that means that the positive ICF change, I'm going to put appears to move down the axon. And this is called a local or ionic current. So it travels down the axon. Now with a myelinated axon, we have a process called saltatory conduction. And basically, this means to leap. I believe in Spanish, saltar is to leap or to jump. So what happens here is the action potential is conducted from one node of Ranvier to the next. Because the myelin acts as an insulator. And an insulator does not conduct electricity. And there are lots of Na plus channels at the nodes. What this does is it speeds up the action potential propagation. So having myelin makes it go a lot faster. So here's a diagram that shows what is going on. So remember that this myelin wraps around the axon, but then every so often we have these nodes. These nodes are places where the myelin does not cover it. So this is where we have a concentration of sodium channels. So the sodium can rush in, which causes the action potential to generate here. But since it can't do anything here, the current travels down and it causes the gates here to open and causes an action potential here. So it's jumping from node to node. And that is what saltatory conduction is. It conducts a current that jumps from the non-insulated places or the places that are unmyelinated.